Right, so our next new law is called the exponent, fraction exponent. Okay, so that's the fifth one, fifth group. Okay, so if you just look at the rule, right, a to the m over n, then the exponent in the denominator, okay, this one, right, this is the denominator, will go to the outside of the radical. Okay, so when you have a fraction exponent, it actually become square root or cube root, okay, depending on what kind of number on the outside. Okay, the outside number, let's give it a name. This is called the index. Okay, the index number will be the same as the denominator of the exponent, right? Denominator. So denominator becomes the index, okay? Denominator become the index. So just remember that, okay? Denominator is the index. So why does it work like that, right? I cannot just throw this rule at you and then say, okay, just remember this, okay? So let's see why this works like that. How come when you have a denominator in the exponent, it becomes a radical? So here we'll use a simple example like 25 to the half and see what happens, right? How do I simplify 25 to the half? So we are going to borrow some of the rule that we already know, okay? The 25, I'll copy this down first, right? 25 to the 1/2, I'm going to rewrite it differently, okay? Without changing the numbers. So 25, I can write it as 5 squared, right? And the outside is still half. I'll use a different color. Okay, any questions so far? I'm just rewriting the 25 as 5 squared. Nothing has changed, okay? And then because of our third law, saying that when you have exponent next to each other, right, the 2 and a half, they're both exponents, right? Then we can multiply the exponents together, okay? So we can multiply 2 by half. And what's 2 times half? Brennan, what's 2 times half?
1.
1, right? So it gives you 5 to the 1. So the answer will become 1. 5 to the 1 is 5, okay? So 25 to the half, you end up with a 5. So what other things can do the same thing? Right? 25 to the half, I want to somehow put something on the 25 so it can also become a 5. So the only thing that could work, right, is having a square root. So the square root is the same as 1/2, right? Having a 2 on the outside, and then the 1 in the numerator is the same as the 1 on the inside. Okay? So that's what it means. So for example, right, let's say if we have, let me move this up. Oh, maybe I think we should have enough space. Let's try another one, okay? Just one more example. Let's say we have 125, right? And then instead of 1/2, let's say we have 3/2, like this, okay? So let's do something different. 2/3, okay? 2/3. Okay, so 125, I can rewrite it as 5 cubed, right? 5 times 5 is 25, times 5 again will be 125. So I can do similar, right? 5 to the cube to the 2/3. Okay, and then because they're both exponent, right? The 3 and 2/3, I can write it as 3 times 2/3. Okay, so 3 times 2/3. What is the answer to that? Aaron?
Wait, what?
Over here, 3, the exponent of 3 and the exponent of 2/3, they will multiply together, right?
Yes.
What would that equal to?
Uh, 6/3. What is
Which
this?
will become 6/3
2
can
over.
become, hmm?
It's 2.
2, very good. Okay, so it ends up as 5 squared. So of course that will equal to 25. Okay, so if I rewrite the exponent, okay, this is the first example on the top. This is the second example. If I rewrite the 2/3 using the radical, right? Remember the denominator is the index, right? So let's try that. Denominator is 3, so our index is 3, right? And then the numerator will be the exponent, right? So I'll put the 2 there. Okay, so what I'm going to do is I can, of course, I can rewrite this as 125. I can do the cube root first, and then outside is a square. I can do the square on the inside or square on the outside. Okay, let me put a bracket, okay, so you can see clearly. So the first way you can write this is having the square attached on the inside. Or if you like, you can put it on the outside, do the square later. I prefer the second way, okay, because it makes the number smaller first. So cube root of 125. What is the cube root of 125? Eric? Eric? Eric,
Sorry, my mic wasn't working. Yeah,
what is it? What's the answer?
4 or 2.
Huh?
Wait, then isn't it just 5?
5, yeah. Okay, so it'll be 5 on the inside, and then outside you still have a square. Right? So it's the same as what we got at the end. Okay, so these are just 2 examples to show you why the fraction exponent is does the same thing as a radical. Okay, so a radical could be a square root, could be a cube root, right? Even the fourth root, depending on whatever the denominator is. So just remember the rule here, right? Denominator becomes the index. Okay, as long as you figure out it's the denominator that goes out, all right, not the numerator, okay, denominator goes outside, then the rest will be easy. And when you have a mix of numerator, denominator, we prefer to do the denominator first, okay? It makes the number smaller. Because if you want to evaluate the inside, right? If you look at this one, 125, you want to square that, takes much longer, right? You get a huge number if you do 125 times 125. And then even harder when you try to do cube root of that, right? So instead, we'll do the cube root first and then square. Okay? Any questions? Can you raise your hand if you understand everything so far? Okay, Aaron and Eric. Okay. So we are gonna look at one more. Okay, what is the value when they say what is the value of 2 to the 5 over 3? If it's asking like the last two questions, right? If it's asking the value, then you need to as far as possible. So for the second one down here, you will say it equals to 25. Okay, then that will be the value. Okay. So remember, you don't use calculator. Okay, just go as far as you can. So for example, like this one, what is the value of 2 to the 5 over 3? So just remember denominator is indexed. So you would have indexed and then 2, right, to the 5, right? That's one way, right? But then since the inside, right, I cannot find the cube root of 2, okay? So another way, right, you can write or. You can have the 5 on the inside, 2 to the 5. Okay, and then that way you can at least do a little bit more. 2 to the 5, what's 2 to the 5 equals? 2 times 2 is 4, right? 4 times 2 is 8. 8 times 2 is 16. Times 2 again, 32, right? So you can write it as cube root of 32. So you just go as far as you can, okay? You don't need to find the cube root of 32 because it will turn out to be a decimal, right? It's not a perfect cube, right? 32 is not a perfect cube. Then you just stop there, okay? So you also need to know when to stop, okay? You can stop in either this way, or this way, okay? When they say please find the value. I will prefer the last one, okay? Because that one has less exponents, right? Okay, let's look at the following 4. I've chosen 4 questions here. These are the 4 different types, you can say, right? It gets harder and harder, okay? So here it says evaluate. Question A, denominator is index. So how do I write it now? You sure? 3 to the half.
3 square root.
Okay, 3 square root. That's it, right? Yeah, okay. When you have a square root, you don't need to write a 2 on the outside, okay? If you see nothing, it means square root, okay? So we just leave your answer like that. Also the 1, right? The 1 is with the 3, but you don't need to show the 1, okay? It's invisible, okay? So if the index is 2, it will be invisible. If the exponent is 1, it's also invisible, okay? We can make a note. These are invisible. If you don't see it, it means it's there, okay? Okay, second one, we'll turn this into radical form, okay? So this is called the radical form. Radical form. And this is the exponential form. Okay, please write this down. We have 2 different forms. Okay, question B. How do I turn this into radical form? Okay, Aaron, can you try this one?
You do cube root.
Cube root. How
Wait,
do you?
no. Square root of 4 to the power of 3. you
Yeah.
can put the 3 outside.
Yeah, okay. Let me write that down. Square root 4 and then cube on the outside, like that, right?
Yes.
Okay, anything else?
You square root the 4 into 2,
Mm-hmm.
and then you could add the third power,
Yeah,
which
and
will
then,
be 8, I'm pretty sure.
very good, okay? So if the question says, please evaluate, then you need to stop here. Okay, evaluate, then you have to go as far as you can. But if this question says, please write the answer in radical form, then you will stop there. Radical form. So you got to read the instruction, right? So do not do more or too little of what's being asked, right? If you do more, you might get a mark if your teacher is not so strict, right? But if you do too little, it says evaluate, but then you stop at radical form, then for sure you won't get the mark for it. Okay, so make sure you write these notes down, okay, what each part represents. Because the question says evaluate, then you stop at 8. For question A, we stop at radical form because that's as far as we can go, right? I cannot square root the 3 because it's not a perfect square, okay? So you will just stop there. If you are able to continue more, like question B, then you do more. Okay, let's look at C. Now C has a mix of two things, right? You have a negative there, right? You have a negative 2/3. So your exponent is this. This is your exponent. Okay, so exponent not only has a fraction, but also has a negative sign. So you just do in the order of in the order that you learn, right? You learn negative exponent first, right? Remember when you have, if it's 2 to the negative 3, it will flip, right? Become 2 to the cube. So that's how you use up the negative sign. So I would like to know, how do you use the negative sign here? Okay, Colin, what do you think? If I just apply the negative, what does it look like?
Can you repeat that?
If I use the negative exponent, what would the question become?
Is it just like the same thing, like 1 over cube root of 27 squared?
Okay, yeah, very good. Okay, I'll do it slower. You'll bring everything down to the bottom, but then you keep 27 to the 2 over 3, 2/3. And then you apply, so this first step is just using up the negative exponent, okay? And then you apply the denominator, become the index. So 1 over cube root, and then 27, you can put a square outside, okay? We'll deal with the square later. Okay, so this is called radical form. If they say, please leave in radical form, you stop here. But since the question says evaluate, you got to continue more. Okay, Nathan, how do you continue from here?
You would do like 27 cubed, so it would be 3, and then you would do 3 squared to be 1 over 9.
Yeah, very good. Okay, so 3 squared, and that will give you 1 over 9. So 1 over 9 will be the answer for evaluate. Okay, so two different answers depending on what they ask. Okay. So question D. Question D has a variable, right? Has a variable means you won't get a number at the end. You'll still have a variable there. So this one, you just, this is just a practice of how you apply the negative and the radical, okay? So go as far as you can. I'll let you try D first by yourself, okay? And you can raise your hand if you get something. Okay, just write whatever that you think it should become, okay? This one, you can't really get a number out at the end. You just have an expression that has X inside. Okay, please raise your hand if you already got something down. Okay, Eric, what do you have?
I have 4 times 1 over, or 4 over square root of x.
Okay. All right, very good, thank you. So the thing I'm trying to asking you to see is that this one doesn't have brackets, okay? So the negative exponent, the negative half, only applies to the x, okay? So you should compare with when you see a question like this one. Okay, one has bracket, one doesn't, okay? So because it doesn't apply, doesn't have brackets, so only the x can be moved to the other side. So your first thing that will happen, it will be 4 over x to the half. Only the x has an exponent. And then denominator become index, so that will be that, okay? So Eric is right. If it has bracket, that means everything in the brackets gets to move. So everything moves down. Okay, so your answer should be square root of the whole thing. Okay, so that's the difference I'm trying to show you. Okay, so I want you to pay attention whether the question has bracket or not. Makes a very big difference. Okay, any question? Okay, last thing, now you understand that the denominator is indexed. There are some situations that the answer is undefined. Okay, since when you get a radical, there are scenarios that you can get undefined. So let's look at the following 4 examples. Okay, so when will the answer be undefined? Undefined means there's no answer. Okay, it's when you have even index. Even means 2, 4, 6, 8. Okay, and then you have negative on the inside. Even indexed, negative on the inside, negative inside. So let's look at first example. The index is 2, right? Square root of 25, the index is 2. Inside is positive. Right, so this one should be okay, right? This is square root of 25. So this one just simply 5, right? Just like square root of 9 is 3, right? It's okay. And we can also quickly check, right? 5 times 5 makes it 25. So that's why it works. Okay, so the next one, the index is 2 again, but the inside is negative, right? Negative inside. So this one fits the rule here. you have an even index and then negative on the inside. So this one should be undefined, meaning you cannot find the answer. But the question is why? How come we cannot find the answer? Anybody know? How come this one is undefined?
Because two negatives will always equal a positive.
Very good, okay? We are unable to find something square to make it equal negative 25. It's impossible, okay? For the previous question, we can find something square, make it 25, right? The answer will be 5. 5 times 5 will be 25. But for number 2, right, it's impossible. Any two negative will always be positive, okay? So make a start on this one. Okay, so remember the rule. When you get a negative inside, then you check the index. If it's even number, it's undefined. Okay, now for the third one. Okay, number 3 and number 4, you can think of it as a pair. Okay, number 1, number 2 is a pair. Number 3, number 4, they have index of 3, right? So they are odd numbers. Okay, so the third one, we have cube root of 8, right? Cube root of 8, because if it's odd, this one is odd. So it doesn't matter the inside is positive or negative, it doesn't matter, okay? We can always find the answer. Cube root of 8 is 2, right? Because 2 times 2 times 2 will be 8. Okay, for the next one, you have a negative on the inside, so we are looking for something cube will be negative 8. What number will work, Nathan?
Negative 2.
Yeah, negative 2 is possible, right? So it'll be negative 2. So the only one that could have problem is number 2. Okay, this is the only one you have to watch out. So it doesn't have to be negative 25, right? Could be negative 49, right? But you make sure if the index is even number, then you just say it's undefined. Okay, otherwise you should always get an answer. Okay, so simple rule there. Now we are just gonna practice changing the form, okay? So we'll do question 3. Question 3, you don't need to evaluate, okay? Remember, this one it says turn it into radical form. Okay, so just leave your answer in radical form. Do not evaluate the exponent. And okay, I'm gonna call Sarah, see what happens. Okay, so you can work on question 3 right now. Okay, if you finish, you can raise your hand. Some question has brackets, some question has no brackets. Well, actually only one has brackets. And then some question has negative exponent. Okay, remember you don't need to evaluate, just leave it in radical form. Okay, has anyone finished yet? Only 8 questions. Please raise your hand if you're done. Okay, Aaron, question A, what do you have?
Root 25.
Yeah, root 25. Good. Okay, so remember, you just leave it here. Do not answer 5. Okay, you'll get it wrong. Okay, question B. Yosher?
Cube root of 5, 4.
Yeah, cube root of 5 to the 4. You can either leave it like this, or you can put a 4 on the outside. Either way, okay? Both of them, you'll get the correct answer. Okay, Nathan, how about C?
9 to the power of 3 inside, then 4.
9 to the power of 3.
Oh, it's a -1.
Huh? Say that again.
Like 1 over.
Oh, 1 over, okay.
Yeah.
1 over, like that?
Yeah, and then there's like a square root, and then over that thing, over the 9, yeah. And then the 4 outside.
Yeah, okay. So next time you can say this is called the fourth root. Fourth root of 9 to the cube, okay? Okay, very good, that's correct. Okay, you move the 9 down, and then the denominator become index. Okay, Eric, question D, do you have it?
Yeah, I have negative 25 to the root second root and then to the power of 5.
Oh, negative, is negative inside the root or outside the root?
It's outside, so negative bracket square root of 2. I mean square root of 25 bracket 5 exponent of 5.
Like that.
Yeah.
Yeah, okay. So this one, having a bracket or not, it doesn't matter, right? So you could also leave it as negative root 25 to the 5. Okay, that's one way to write it. Or you can write it as 25 and then have the 5 inside. Okay, you can do put it outside or inside, like that. Okay, so any of the 3, you'll get a mark. Okay, I'm just showing all the different ways because maybe some of you do it differently. Okay, question E, Brennan.
1 over x of
1 over root x to the power of 3.
Square root x to the power
Yeah.
3. Okay, so once again, the cube, the 3, you can put it outside or inside. Okay, doesn't matter. Okay, question F, Colin.
1 over 4th root of k to the 3.
Yeah, so you can put it like this, or 4 through k to the 3. Okay, either way. Okay, question G. Yoshi.
Cube root of 5x.
Cube root of 5x like this.
And then bracket on the outside 2.
Okay, square. All right, so you can put a square there. If you want to put it inside, you can write it out like this, 5x, and have bracket inside. Okay, so the square is affecting everything inside, right? The 5x. Okay, question H. Nathan?
5x to the squared and then over the under the cube root thing.
Which one is under the cube root?
The 5.
The 5 is also
The whole
included. The whole thing like this?
Yeah.
Okay, how do you know the 5 is included?
It's not because there's no brackets with it in the x thing.
Okay, so where should we put the square root then?
Just over the x.
Yeah, over the x, okay? So in fact, this is a cube root, right? Because there's, you compare g and h. I put them next to each other so you can compare, right? So 2 over 3 only affects the x. X is the base for the exponent. So only the x has the cube root. Okay, so we need to write it so then the 5 is not so close, right? What you can do is you put a bracket around the cube root there. Okay. Okay, so this is if they say write it in radical form. Okay, then you do it like that. Okay, turn all the exponent to radical form. Now the next part is sort of going backwards. Right? You see every question has radical. Right? In question for everything is in radical. You want to go backwards and write it as power. Write as power means has a base, right? Has base and has exponent. Okay. Not only that, it also says please keep it in positive exponent and simplify. Okay, we'll do a few of them together. Okay, these are a little bit confusing. Confusing not in the way that it's hard. Okay, confusing is because not sure what answer you want to leave it in. Okay, some question you want to do more, some question you want to do less. Okay, so what does it mean simplify? So I'll show you what it means. Okay, so when you're doing homework, make sure you refer to this page. So this one, the first one is pretty simple, right? Just square root of 28. We want to write it as exponents. Okay, so Brendan, what's the answer for A?
28 and to the power of 1 over 2.
Yep, very good. So we want to go back. Index is the 2. It becomes denominator. Okay, go backwards. Okay, let's try question B. You guys try it out first. I'll give you about 10 seconds. Write out the power form. Power form means has a base and an exponent. Okay, Colin, how do you write this one?
Negative 13 to the power of 2 over 3.
2/3. Okay. Anyone has
I
some
have, I have brackets too.
brackets around where?
-13.
Okay. Anyone else got something different? Does everyone have the same?
-13 and 1/3.
You have -13 and 1
Well,
over
brackets and then 1/3.
bracket to the 1/3. Okay. Anyone else?
I got 1/3 as well.
1/3. Okay. So where's the 1/3 come from? So we have to look, right? We know the index become the denominator, right? And then the numerator should be the exponent on the inside, but inside there's no exponent, right? So it's invisible. So it should be the invisible one, okay? So therefore it should be 1/3. Okay, so if there's a 2, right? If it's 2/3, then you should see a square somewhere, but there's no square, right? So it should be just 1/3. Okay, question C. Okay, now starting from question C, things gets more confusing about how much you want to simplify, okay? So first, please write out the radical form, okay? Same thing, I'll give you about 10 seconds, write out the radical form. Okay, and raise your hand when you got the radical form. Sorry, not radical form, exponential form. See, I'm confused now. Okay, turn it into exponential form. Colin, Eric, Nathan, any trouble? Okay, Eric, can you give it a try? What does it look like in exponent form? Eric?
I have 5 to the power of 1/2 times x to the power of 2.
Okay. Okay, anyone else got something different? Everyone's the same? Okay, so let's see if we show the step, okay? See what they will end up with, okay? So first thing is notice that everything on the inside is under the roof, right? Under the square root. So index is 2. So you make sure you keep the brackets, 5x to the 4, and then denominator should be 2 and half. That's only the first step. Next step, you need to apply the rule that you learned from before to simplify, okay? You need to continue, share in the exponent. And you want to leave it as exponent. So 5 to the half, give you the first part, and then the 4, exponent of 4 will multiply by half will give you the 2, okay? So that's how you get 5 to the half and x squared, okay? It's correct, very good. Okay, so you don't need to turn the 5 to the half into square root of 5, okay? You don't need to do that because it says leave it an exponent, write it as power. So just leave it as 5 to the half x squared, okay? So if you understand that one, right, you can try D. We'll do 3 more, okay? I'll let you guys do D, E, F, and then we'll go over all 3 together, okay? You can raise your hand when you finish D, E, F. Okay, that's okay. Look at D. Okay, well, Yoshir, what's your final answer look like?
Bracket negative 8x bracket 1/3.
To the 1/3, like that? Did you stop there?
Yeah.
Okay, this one, we need to do another step, okay? If you want to simplify more, okay? So for the next one, okay, let me move it up, okay? So this is the part that you need to know when to stop when they say simplify. Okay. So first step, you write it in radical form. And then just like question C, the exponent needs to go in, right? So you will get negative 8 to the 1/3, x to the 1/3, right? So then that will look like question C, right? You already shared in. In question C, we just stop there. Question C, we have 5 to the half and we stop. This one, we cannot stop yet. Okay, the negative 8 to the 1/3, you need to do one more thing because it says simplify. So you want to go as far as you can, especially when it has a variable and a constant, right? Similar to last week, remember when we have variable and exponent together, we want to evaluate the coefficient, okay, the numbers. So same with this one. Okay, so negative 8 to the 1/3. What can we do, Brendan?
You can change that -2.
Yeah, okay. 1/3 means a cube root, right? So it become -2. Let me write it down. -2. And then x to the 1/3. So this is where you should be stopping. Okay, when they say simplified. The last question we did not do that, right? Because 5 to the half, there's nothing else you can do. Right? You cannot square root of 5. Okay, so that's why I stopped there. But then for negative 8 to the 1/3, you know that you could cube root of negative 8, right? So you need to do one more step. Okay, put a star there. Okay, you need to do more steps. Next one is xy to the 2 to the 1/5. Right, that part I think everybody gets. What else should we do? Nathan?
You have to like distribute it into everything.
Yeah, so it becomes
X to the 1/5, and then Y, and then Y to like 2/10, I think. 2/5.
yeah, 2/5. 2 times 1/5, same as 2/1, right? Times 1/5, so 2/5. And there's no coefficient here, right? So that's it, okay? This is as far as you can go. Okay, so this is if they ask you to change it to power, okay? Last one here. Okay, so first thing we write in radical, exponent form. So it'll be -3 x to the 2/3, right? Index become the denominator. What should we do now, Colin?
I just expanded it inside.
Yeah, becomes.
So bracket -3 to the power of 2/3,
Mm-hmm.
and then x to the power of 2/3.
Yeah, very good. Okay, and because the over 3 means cube root, but cube root, I cannot cube root a -3. Okay. So it's not difficult, it's only confusing on where you need to decide when is the best place to stop. Okay, so these 6 questions will work as a template, right, for you to check. These are examples, right, to help you determine when to stop your answer at. Okay, if you have any more questions, you can stay after class. We'll call it a day. And have a great weekend. See you next week.
Thank you, Jason.
You're welcome.
Thank you.
You're welcome. Bye bye.